Well, let's talk about some of the best practices for identification and authentication. And the first thing is get rid of or disable system accounts. All right, every system I know has default accounts. In Windows, we have the guest account. You want to disable it. There's an administrator account, named administrator. You don't have to use it. You can make your own ones. Also, you should know that if you have an unused account, that at some point it should be deactivated. And that's important because unused accounts are ways for people to get in and maybe not anybody noticing because, it's not anyone's account. So if I know, let's say Fred has retired and nobody's deleted his account, well, I'll just start logging in as Fred. And if it gets locked, that's okay. I know over time it'll unlock, and I'll try some more passwords. And nobody's going to know unless they're looking at logs because Fred's not going to call and say his account's locked out. Automatic disconnection of an idle login session, very, very important. Especially when we look at network infrastructure devices like a router or switches. If I use a console port, that's where I can take my computer, plug directly into that router. It's going to stay, unless the person there is actually logged out. When I plug in, I'm going to be using their session. They won't ask me who I am or anything else. It's not got that kind of an intelligence in its operating system. Whereas if they left and after 5 minutes of idle, it locked it out automatically or disconnected it, then I can't use that account. Have minimum length passwords. Today, they say 8 characters minimum. I want to go for longer because I know how easy they are to crack. Complexity of passwords. I'm more concerned about the length of a password than the complexity. Give me an 8-character complex password, which means it's at least 3 out of 4 of the following: uppercase and lowercase letters, numbers or numerics, and special characters. Give me a complex 8-character password. I can probably break it in about 2 minutes. And I'm not kidding about that. Not because I'm some mathematical genius, but because there are rainbow tables that do that. So you need to take into account, what the policies are. But it's also, I think, important that you kind of look at what the current security trends are as you make these comparisons. No John Doe passwords. And people say, what's a John Doe password? Well, let's say my name is Ken. I'll make my password Ken. Right? You don't do that. That's an easy one to guess. And you need to have password account policies. Again, how long until the password expires? Can you reuse the same password? Right? Some keep track of password history, so you can't reuse that same password until maybe like the 15th time you've changed it. How long can you wait in between changes? If I'm sitting there saying I've got a favorite password, and I know that if I change it, I can't reuse my favorite password, but if I change my password 15 times in a row, then I'll get to the point where I can use my old password again. Right? So make them wait 2 days, 3 days in between changing. Lots of options you have. You can also take a look at authentication devices like tokens and one-time passwords. Now, smart cards and token generators are some of your best options that you can use. And the reason for that is that it adds into the authentication, right? And you get into the 2-factor. Because not only do I need my username and password, but I have to have a card that I can plug into a machine that it can read it and verify that it is me and that it goes with that username and password. The token generator, you see people with these things hanging around their necks on their when they're at work, or they have them attached to their keychains. But what it does is that when you go to log in, then you get a challenge from the server saying, okay, give me a token. And you look at the device, and it might give you what number you just type in because it's synchronous. Or you might have to type a little PIN number challenge in and see what the answer is and type the answer in. But either way, if you didn't have that little device, you couldn't log in. The other part of that was the biometrics. Now, in biometrics, we have a lot of options. You have a palm scan, kind of like the idea of a fingerprint scan, that we're looking for the certain patterns. There's also a hand geometry, the size of your hand, the length of the fingers, those types of things that can be used to identify you. With the eye, we can look at the iris or the retina. The iris is the coloring patterns around the pupil. The retina is the capillaries in the back of your eye, so it actually has a scan inside. Face recognition, you've probably seen a lot of that on TV shows. Signature recognition, voice recognition, kind of get you into something you do, but it's still under the biometrics. Now, when it comes to the biometrics, management should address effective security for the collection, distribution, and processing of biometric data. And that should encompass things like the data integrity, authenticity, and non-repudiation. You know, I saw a grocery store in Minneapolis that for a while was promoting this ability for you to link your debit card into their database, and you would put your thumb on this thumb scanner, would scan your thumb, so that the next time you came to the store, you could just put your thumb on this little thumb scanner and it would automatically identify who you are and debit your card for whatever your grocery purchase was. And I'm thinking, okay, aside from the fact that we know biometrics have times when they have false positives, where they authenticate somebody who's not that person, and false negatives where they won't let me get authenticated when it is me. Beyond that, I have my information now being stored somewhere in their databases. And so it made me think, you know, how good is the integrity of the information, the authenticity, the non-repudiation, and basically, you know, understanding, you know, did it change? How do I know that somebody didn't find a way to associate their thumb with my account? You know, those are things that you think of. You also have to figure out how to manage that biometric data. We also have to deal with the use of biometric technology. Not everybody likes to put their eye up to something that's going to shine a light into it and take a look in the inside. We also have to, as I said before, deal with error rates. And every biometric device you look at is going to have evaluations of false positives, false negatives, and where they kind of intersect. You'll see this called as an error rate that you can look at and rate the effectiveness of the hardware you're buying. That also means you have to figure out how to apply the biometric technology. Now, I see that a lot in entryways to get into a door, handprint or thumbprint to get in. We're seeing it even on laptops today, where you have to slide your finger over this little scanner that's going to look at your fingerprint and see if it's you. So you need to know where you're going to apply it. How's it going to work? Encapsulation of the biometric data. You know, that device that's reading it has to turn it into a bunch of ones and zeros and somehow get it out to a device to do verification. That means we have to have techniques for securely transmitting biometric data. We also have to secure the actual physical hardware. I mean, you see, I'm sure, lots of great movies of people breaking in by dusting for a fingerprint and putting that fingerprint in that little reader while nobody's looking. Well, maybe you have to have different types of security. And what else do we have? And techniques, of course, for integrity and even in the privacy.